This video is about identifying slope of a line given 2 points, and based on slope, determining whether lines are parallel, perpendicular, or neither. So remember from Algebra 1, we've talked about slope before. So slope of a line in a coordinate plane is a number that describes the steepness of a line. Any 2 points on a line can be used to determine slope. So when we do slope, remember we're comparing our rise over our run. So the rise is the difference in the y values. The run is the difference of the x values. The slope then is the ratio of the rise to run. So if x1, y1, and x2, y2 are any 2 points on a line, then to find the slope, we use our slope equation, y2 minus y1 over x2 minus x1. Remember with slope that there are 4 possible outcomes. So when we do slope, we can have a positive slope, which means the line's going up from left to right. We can have a negative slope where the line's going down from left to right. We can have a zero slope where the line is horizontal, and we can have an undefined slope where the line is vertical. In Algebra 1, you also talked about parallel and perpendicular lines. So parallel lines are 2 or more lines that never intersect. The slope of the parallel lines are the same. So if I have a slope of 1/2 and 1/2, those lines would be parallel. Perpendicular lines then are lines that intersect and form a right angle. The slopes of perpendicular lines are opposite reciprocals. So opposite means that one of them is positive, one of them is negative. Reciprocals mean that they are flipped. So some examples would be 2/3 and -3/2, or -7 and 1/7. So let's complete the chart of our slope. So we have slopes that we are given. We want to find the parallel and the perpendicular slope. So remember that parallel slopes are going to be the same. So if the slope is 2/3, our parallel slope is also 2/3. Our perpendicular slope is the opposite reciprocal. So because it's positive, the perpendicular slope is negative. And then we flip our fraction, so the numerator and denominator switch. So we have -3/2. If our slope is -5/4, our parallel slope is also -5/4. Our perpendicular slope then, since the given slope was negative, our perpendicular slope is positive, and then we do the reciprocal of our fraction, so we have 4/5. In the last one, our slope is -2, so our parallel slope is also -2, and our perpendicular slope then is 1/2. So we want to determine whether the lines are parallel, perpendicular, or neither. So we're going to be given 2 names of lines that we need to find the slope for and then compare them. So in number 2, we want the slopes of AB and CD. So to find the slope of AB, remember that our slope equation is y2 minus y1 over x2 minus x1. So for the slope of MB, we have 5 minus 1 because we have 5 as a y-coordinate and 1 as a y-coordinate. And on the bottom, 1 minus 2. So that would get us 4 over -1, which reduces to -4. For CD, we have -2 minus 2 over 5 minus 4, which gets us -4 over 1, reduces to -4. Because these slopes are the same, we now know that they are parallel. In number 3, we want to find the slope of ST. So we have -1 minus 2 over 5 minus -2, so that gets us -3/7. Our slope of UV, we have -4 minus 4 over -1 minus 3, so that gets us -8 over -4, which reduces to 2. They are not the same slopes, they are not opposite reciprocals, so this is neither. So our next 2 lines are FG and HJ. So when we do the slope of FG, we're going to have 2 minus 1 over 2 minus 1, which reduces to 1 over 1, which is 1. And then we have the slope of HJ, which is 2 minus 1 over 1 minus 2. That is going to get us 1 over -1, which reduces to -1. If we go back and look at these unreduced slopes, notice that they are reciprocals because 1 over 1 flipping to 1 over 1 is still a reciprocal. One is positive, one is negative, so these lines are going to be perpendicular. Pause the video and try number 5 on your own. So after we find our slopes, we see that MK has a slope of -7 over 2 and MN has a slope of 1/4. So they are not the same and they are not opposite reciprocals. So this would be neither. In number 5 and 6, we want to draw parallel lines. So in number 5, it says draw a parallel line to the given line through the point 4, 3. So first thing I want to do is I want to find the slope of this line. And I see that's going down from left to right, so I'm going to have a negative slope. So I want to count how much did I go down and how much did I go over by using the grid line. So I went down 1, 2, 3, 4, so that's -4. And then I went over 1, 2, 3, 4, 5, 6, 7, 8. So to find the slope then, I would have rise over run, -4 over 8, which reduces to -1/2. My parallel slope then is also going to be -1/2. So now I'm going to plot the point 4, 3. So my x coordinate's 4, my y coordinate's 3. Then I'm going to use my slope to create my line. So I'm going to go down 1, right 2, and then I can connect my line, and now these lines are parallel. So in number 6, draw a line parallel to KS through T. So if I connect K and S, this is one line. Again, I'm going to have a negative slope here. So when I count, I go down 3, and I go over 1, 2, 3, 4, 5, 6, 7. So my slope is -3 over 7. So now from T, the point that was already plotted, I'm going to go down 3 over 7, place my point, and I can connect my lines. We can also draw perpendicular lines. So to draw a perpendicular line, I'm first still going to find the slope just like I did before. So I'm going to find the slope of RA. So for RA, I go down 1, 2, 3, 4, 5, 6. And I went over 1, 2, 3, 4, 5, 6, 7, 8, 9. So my slope is -6 over 9, which is -3 2/3. Now, if I want the perpendicular slope, that is the opposite reciprocal. So I'm going to remove this so it's not in my way. Since I do want these lines to intersect at a right angle, so the opposite reciprocal, if it was negative, it's now positive, and I flip my fraction, so it's going to be 3 over 2. So from H, I'm going to go up 3 over 2, and I'm going to do that until I cross through my line. And then I can connect my points, and those are perpendicular. They would form a right angle where they intersect. In number 8, we want to draw a line that is perpendicular to AC. So AC is going to have a positive slope. So when I look at the slope of AC, I went up 7 and over 2. So my perpendicular slope is the opposite reciprocal. So instead of being positive, it's now negative, and I flip my fraction to 2 over 7. Now, if I go down 2 over 7, I run off the graph, and my line is the other way. So instead of going down and to the right, I'm going to do the opposite. I'm going to go up 2 and left 7. I'm going to do that one more time, up 2, left 7, and then I can connect my lines, which would be perpendicular and form the right angle at their intersection. In number 9, find the slope of each line and then use geometric symbols to state which lines are parallel and perpendicular. So the line from ST, so I want to figure out what the slope is from S to T. So from S, I go up 1, 2, 3, 4, 5, 6, and we went over 9. So my slope is 6 over 9, which is going to reduce to 2/3. Always reduce your slope. Then we have the slope of MS. So we're still going to start at the point that's further left. So this time we would go down 1, 2, 3, 4, and we would go over 8. So negative 4 over 8, which is negative 1/2. For TK, we would go down and over. So we went down 6 and over 4. So we have 6 over 4, which reduces to negative 3 over 2. And our last slope then is Km. And for Km, we went up 4 and over 5. So we want to use our geometric symbols to state which ones are parallel or perpendicular. So if I'm looking, I have no slopes that are the same, but I do have 2 slopes that are opposite reciprocals. So we know that line ST is perpendicular to line TK because the slopes are opposite reciprocals. So let's try one more problem here where we want to find the slope. So first we want to find the slope of LO. So for LO, we went down 2 and, down 3 and over 6. So we have negative 3 over 6, which would be negative 1/2. For VO, we went up 3 and over 1, so that would be 3. For EV, we went down 1 and over 4. And for LE, we went down 5 and right 1. So in this case, if we look at our slopes, none of them are the same or opposite reciprocals, so we would have none because no slopes are the same or opposite reciprocals.